customer a compliment? The man deliberately construed the worker's words as insults. Don't construe my silence to mean I agree with your ridiculous plan, the man said. Your suggestion was so dumbfounding that I was merely at a loss for words. He finally construed the meaning of the text after reading the poem a fifth time and looking up every word in the dictionary. The man wanted to buy the widow's priceless Rolls Royce, but did not want to come right out and ask her. He hoped that she would eventually construe his intention after he dropped a bunch of hints and innuendos. Here's impunity. And impunity is the get out of jail free. And it means to escape from punishment. The employee thought she had impunity because she was related to the boss, paternal third cousin twice removed, and she'd been there for 3 months. That's the only thing that could explain her riotous behavior. Your average citizen cannot break the law with impunity. In a fair and just society, nobody can. In Monopoly, a player can leave jail with impunity if they cash in their get out of free jail card. Get out of jail free card. Ending impunity for blatant criminals was the mayor's first order of business. And then apparently the healthy looking 20-something could eat fast food every day with impunity, apparently. The illusion did not last forever, and eventually he affected a pickle look. I think it's maybe my mind was on my somebody in my family did that. Like it works between the ages of 18 and 25, and after that you're like, affects your appearance. All right. So what does, see this woman eliciting responses from her partner? What does elicit mean? Does it mean freedom from punishment? To make a deduction? To put up with or to bear? To draw forth? Or harmful, causing injury? Who knows the answer to what elicit means? The joke was so bad that the comedian failed to elicit a single laugh. Remember that one?
What is elicit?
Do you have some?
Draw forth.
Okay, what about pernicious? Pernicious lies, pernicious coy. Does it mean freedom from punishment?
No.
To guess, to put up with, or harming, causing
To put up
injury?
with is tolerate. I think elicit is
We already got elicit. It's to draw forth. What about pernicious? Does it mean harmful?
Yeah.
I think pernicious means that.
Like pernicious lies?
Yeah.
Okay, what about construe?
I think that's to make deduction or to infer.
What is it called?
And then impunity is the last one.
Freedom from punishment. Okay. So illicit means to draw forth. Pernicious means harmful, causing injury. Tolerate means to put up with. Construe means to make a deduction, to infer, to figure out. And impunity means freedom from punishment. The border guards allowed the doctor to cross the frontier with impunity, illicit, pernicious, construed, or tolerate.
Wait, which one was in one?
Yeah, the border guards allowed the doctor to cross the frontier with blank. Any guesses?
Impunity?
Impunity wasn't it freedom from punishment?
Yeah, it seems like this frontier was like closely guarded, maybe during war.
Tolerate.
It isn't easy to tolerate answers from a sleepy class on a Monday morning.
It really
I think
is.
it's tolerate.
Call, art imitates life. Dentists appreciate patients who can, oh, wait a sec,
Oh,
no, dentists appreciate patients who can tolerate pain.
it isn't easy to construe answers
No, that was an even better one.
to elicit. Would construe work for that too?
Not as good, but probably. They're both verbs. She hoped that we would not blank her decision to run for office as a thirst for power. Our words left over are construe and pernicious.
I think it's construe.
It's like making meaning from.
We
We hope that we would not make meaning see her decision to run for office as a thirst for power. The dictator's pernicious rules failed to intimidate the leaders of the underground.
We didn't play something.
I'm just trying to print.
We didn't play
Okay. Listen to the. Sorry.
Bananas.
Listen to this one more time.
Bananas.
Mr. Dorsey summoned a representative group of teachers and students to his office
There's nothing. Oh wait, never mind. Wait.
in order to elicit their reactions to the suspension of the football captain. They want to hear about it.
Mr. Dollar, there's no thing on
Okay.
skiing.
He told them that cheating was a pernicious disease that could not be tolerated at our school. He loathed having to discipline our spouse, but unless strict measures were taken, the student body would construe the incident as an open invitation to cheat with impunity. We may lose a football game, the principal said, but we can salvage our self-respect.
Cheers.
Like this video and subscribe to the next time.
All right. So week 35, you can turn that in
Got it.
and open the Tangerine thematic essay rewriting.
Got it. For the commentary for the first one, I just put introduction because it's the introduction, right? For the first quote.
No, you're supposed to say something like, for the first one was about the cigarette?
No, the first one, you said you could copy down the thing or whatever.
Number 1 is a cigarette in the garage.
No, you said for the first, like for the introduction, you could put like this essential question or whatever.
Oh yeah, you already writing your essay?
No, I'm just putting it into the, do we write the essay on the same paper, on the same assignment?
Will be a separate one.
See, like I,
So for the commentary, would you, for the commentary, would you talk about what it relates to, like, the question?
type the exact quote.
You just have to let it sit, it's kind of like a weird.
This stream. Or not.
Oh, well, I can do that.
I like the video.
Oh, okay.
For the commentary, or just like tell them how to spell out.
Oh, I like that. Think so? Your mother. Your mother.
What did you say? I still can't hear you. I get my eyes. Oh yeah.
Yeah.
You have one day. Okay, it's 11.
Until 11. I'm watching the stream.
The stream's still on.
Are you watching it? Is he streaming? Wait, what?
Is this your going on?
Oh.
Continue. Make it really loud. Yeah, I know. He's helping me. Just Aiden's too tall. Right? You're taller than Aiden.
Or
Someone told me to give you this.
no, I did not. Yes.
Do we have to make this out to be able to tell? Huh?
What was that? Attention. Attention. Whoa. Someone sure. Ron. Oh. It's drinking. Hey yo.
Hey, yo.
I'm giving you a bullet. On the other side. You like it?
Beef taco.
Mr. Don, we have to have that much written down on ours. All that stuff.
You wanna write as little as possible.
No, for
But-
the commentary.
The commentary helps put the quote in context. So if you say, there were a lot of characters who were short-sighted in the book, and one was the dad. On page 16, it says, Mom turned to me and looked from pure puzzlement. Well, I'm sure your father was never told any of this information in the month fires. That doesn't help complete thought of how he was short-sighted. So in the commentary, you have to kind of explain a little bit more. It says, this quote, Paul's mom just discovered the truth about a month fires could never be fully extinguished. The quote shows how Paul's dad not only overlooked a major unsolvable problem, but he also didn't tell anyone about it. And then also Paul's mom was willing to cover for her husband who wasn't bad at
So basically, just
The best
continuing it.
approach is to find quotes that speak for themselves better. You know what I mean? This quote isn't quite, a reader who doesn't know anything, who's reading this, won't know what you're talking about with that.
So basically, you're putting, basically telling what's happening in the quote.
Yeah, the commentary, you can start weaving in some of the narrative. You can explain what's happening in the quote. But it all ties into the point that you're trying to make. Andy, do you need a book? Sure.
Gee, I wonder who that could be.
My eardrums. That's it. Come on. Let's go higher.
Are we gonna have time to work on this on Monday or Wednesday or Thursday?
This document, this document is.
Yeah, the plan.
But are we gonna have time to work on this on Wednesday and Friday? Or Wednesday and Thursday?
Who could that be? Gee. I wonder.
Huh? No, delete that. Delete
Bruh.
that. Delete that. Promise. Hey, you have more? No.
Scotland. He's watching Fortnite. He was watching Lachlan and Loser. I'm giving you a little trim. I'm a preacher. I'm gonna sit up. I'm braiding your hair. Scrap them. I'm gonna braid your hair. Oh, there it is.
Your mother.
He was watching Frozen.
What's a tea?
No joke, not so serious, you can put that in class once a week.
Thank you.
So that's all.
Oh my God.
I was just watching Fortnite.
Focus browsing is going on. If I hear any more.
It's not on his computer.
I'm so good at that.
They're stripping it.
That's what you mean.
57. Said, there's no other time to practice. So we did a team that did not practice. And that was the instruction of the team.
I didn't give you the soccer team.
Where's the third? That's it.
No. What are you doing? You just sent it to me, you should be able to just check it out.
Michelle.
What?
Where's the cap? No cap? No cap? Where's the cap? He's not capping. Good lord, we must be focused.
Everybody knows that.
Really hard, like a rock.
I don't know what it is.
But that one already comes but if you eat it like raw, it is something. But there's cheese. Yeah. Wait. Okay, so that's okay. So the one I gave her- the one I gave you already comes with seeds.
Right.
Yeah. Already comes other ones have like Asian top.
Smack, smack, smack.
And it will have like-
It's stuck in my head. Wait. What the
No cocaine.
Whoa!
Hey, yo! No, I didn't mean that. I didn't mean, that's not what I said.
That's what they all said. That's what they all said.
Aiden, this class is crazy.
Cocine! No cocine! Cocine! I don't know why people want to try to explain what's happening over there. No one people came in there. No. According to my Mexican mom. Bro, that's how I can get all the time. Really? You just like, yeah, you don't learn it, give it to them. Exactly. Oh yeah, deal with his heart.
How long is it on for? How long is this on for? Mr. Don, how long is it on for? 12.
Have snacks and snacks, all this history, so let's open one up and uncover the mystery. Let's take a look at Popular Mechanics, February 1963. On the cover, we've got a station wagon with a trailer and an airplane behind it. That is cool. Are you the kind of guy who loves to
What things?
Giant light bulb, operating on standard house grid, 47,300 times brighter than an ordinary bulb. Believed to be the world's largest, the bulb gives enough light for reading 600 yards away. Whoa, what is this? Submarine built by three. Skin divers are protected from underwater hazards in a 3-man plastic submarine. This is what I came here to see. Folding wing planes. I've always wanted to build my own kit plane. My dad is a crop duster, so I've grown up around planes my whole life. So I'm also interested in flying too. Marines wheel out 2 new floating transports. That's cool. Steerable parachute. Oh, that's interesting. A little flap over there. I've never seen one like that before. Oh, now this is cool looking. 3 dimensions on the double. This article talks about a draftsman that can take a 2D drawing and this machine can convert it into 3D. Even though I have CAD, this would still be fun to try. Pick up pedal car for adults. I don't know, I have to laugh because here's a man in a suit in a pedal car, which is generally a child's toy. I'd build one to try out. What is this? A bloated barge? Looking like a fat jack-o'-lantern, a pumped-up bag is actually used by the British military to transport vehicles over water. A musical telephone has a Swiss music box in a plastic case to entertain callers for 20 minutes. Wound by a pulling the cord, it is activated when the handset is placed on the music box screen. Here, hold on a second. Let me play a song when I go to the bathroom. It's a good idea. Good job. We can build a cool toy, the Little Digger.
The what?
Hand size. Little Digger. You just go out there and dig a hole for no reason. Backseat playroom for your Volkswagen Beetle. I love it. No seat belts. They're just rolling around in the backseat. Ooh, steam engine. I want to build a cool steam engine. This one's kind of interesting. Ooh, and good plans too. Oh, look what we got here. Look at that tiny bicycle. He's holding in his hand. Ha, tiny, and he's riding it. Now this is interesting. Colored bicycle. Geared to the regular bicycle pedals, an oversized propeller pushes London cyclists around his neighborhood at speeds of up to 20 miles per hour. The inventor, Ernest Winter, is using his strange craft as an experimental vehicle to test self-propelled flight. He estimates he will need another 5 miles per hour and wings to get off the ground under his own power. He calls his air screw bicycle the Glastonbury Zodiac. Winter and other Englishmen are competing for a prize offered to the man who could fly a self-propelled aircraft. That propeller looks really strange. It's extremely large. It looks like he built it in his garage. I can't see how he drives the propeller. His leg is blocking it. I'm assuming it's maybe a gearbox or some series of belts. My curiosity is raised. I would like to try to build Ernest's air screw bicycle. I think this would be really fun to try. So let's head down to the shop and get started.
Unlimited data usage for
Unlimited data usage.
I noticed in Ernest's photograph is that he's removed the drive chain completely from the rear wheel and only turning the propeller with the pedals. I can't tell in the photograph, but how does he actually get the propeller to turn? And how fast does the propeller spin? And what gear ratio did he use? I also like to know, how am I going to build a propeller? That's going to be tricky. How much air can the propeller actually push? How hard is it to get the bike started on a steep incline? What happens if it's really windy? Can you ride the bike into the wind? Ernest claims that if this bike hit 25 miles per hour and you put wings on it, he can achieve flight. He also says that the top speed he's able to achieve is 20 miles per hour. So I'd like to try to match that first. The only way to get these answers is to actually build Ernest's bike. So let's go do it. I'd like to try to replicate Ernest's bike as closely as possible. So I'm using this. My 1974 10-speed Schwinn Varsity. The Schwinn company located in Chicago started making the Varsity line in 1951. Varsity was a lightweight design, weighing in at 38 pounds, and the first to feature 10 speeds. Schwinn dominated the market, making dozens of models. They mastered the manufacturing of bicycles and coming up with faster ways to weld the frame together. As long as bikes have been around, people have been trying to make them fly, and Ernest is no different. It's been only recently where people have found success with pedal-powered flight, and Ernest has helped pave the way through the creation of his machine.
You got like 3 feet of air that time. Can I try it really quick?
Before we start the project, I'd like to see how fast the bike can go in its original condition. This is going to give us something to compare to when we put the propeller on the back. To track the speed and acceleration of the bicycle, I'm using a cool GPS device called the Sky RC. It uses the power of satellites to track how fast I went and, of course, how high I jumped. So it's the perfect device to track how fast I go on the bicycle. And with the average of the 2 GPSs on my speed runs, I came up with 19 miles per hour. So now that I know that 20 miles per hour is really fast, it makes me a little bit worried about turning a propeller and achieving those speeds. The first step I need to do to make this propeller powered is to remove all the original drivetrain components, the chain, the original sprocket, and everything else in between. I'm going to keep all the original parts just in case I want to put it back to original, but we're not going to need them anymore. Disconnected. Oh, that's going to be so weird to try to go with nothing. Now that everything's disconnected, we need to worry about trying to spin the propeller with our feet. The first problem is the prop shaft and the pedal shaft are not parallel. The second problem is our propeller needs to be up high to clear the ground, but our pedals need to be down low for our feet. Unfortunately, I cannot see in the photograph how Ernest solved these problems. One idea is that he added a gearbox, but it has its own problems. It's going to add some extra weight. It's going to be a little bit hard to mount to the existing bike frame. There's more moving parts. And of course, finding a location to mount it to avoid my legs. Another idea is that we try to keep it simple. And that consists of turning the propeller shaft with 2 pulleys and 1 belt. The belt is pretty flexible and can be turned 90 degrees. I'd like to explore and build this design first because it's much easier to build. It may fail, but that's okay. We didn't put a lot of time into it if it does. So I'd like to replace this sprocket with a pulley, because this whole mechanism is going to be driven by a belt. Now this is where it gets tricky. I don't know what diameter this pulley needs to be, and I cannot see in the picture or the photo how big Ernest's is. I'm cutting this pulley out of 3/4 of an inch 6061 solid aluminum. I copied the original sprocket bolt holes. That way this pulley should be able to bolt right into its original location. So here's the original sprocket with the chain, and here's our pulley. Obviously, one is really thin and one is really thick. So we're gonna have to hybrid both of them. What I mean is, here's a typical V pulley. I need to copy that profile into the surface, but I want it to be close to this thickness to reduce the weight. So I'm gonna reduce the weight on the inside, but keep it fat on the outside. And then I made myself this hub so that I can grip onto it with the lathe chuck. Let's take a look at the pulley for a second. The bigger the diameter, the faster it spins the propeller. So I'm gonna try to target an 8-inch diameter pulley, which is the biggest I can fit into the bike frame. Here's how a V-pulley works. A V-pulley is basically a rubber wedge. It grips onto the belt from the sides with its 40-degree angle. Increasing the tension of the belt draws it lower into the V, squishing it into the sides, creating grip. I really need to get the angle correct, that way the belt doesn't slip when we go to pedal. That looks good. The next part we need to build is the propeller drive shaft.
Hey, yo,
So looking at Ernest's photo, it looks like the drive shaft diameter is maybe an inch, inch and a quarter, 3/4. It's really hard to tell. The actual drive shaft itself is going to be this 4140 piece of bar stock. And why don't I use aluminum? Well, for this exact reason. I want to use these sleeve bearings. They have little tiny rollers inside. The diameter of this is really small. This is a regular ball bearing. You can tell the difference in diameter. For our drive shaft, we need to be giant. If we use the ball bearing, by using the sleeve bearing, we can keep it much smaller in diameter. The reason why I'm using a hardened shaft is because these needle bearings use the shaft as the race. If we were to use an aluminum drive shaft, the bearings will just gall, and the bearings will get clogged up with filings and just not turn anymore. So what I'm going to use to hold the drive shaft is this 1 1/4 aluminum tubing. This is going to give the drive shaft the backbone it needs to stay straight. And this is going to fit right inside of this tube, just like that. This requires a 1/2 thousandth press fit. So we'll have to turn that on the lathe, so this goes inside. And then we want the propeller to push on a smooth rotating surface. So this is a thrust bearing, and it's going to get mounted on the end of the shaft. So when the propeller is pushing, it has a nice friction-free surface to ride on. So we'll have to make sure we add that in. So we're going to keep this package neat and tidy and as small as possible, and we'll recreate this scenario on each end of the drive shaft, and then we can get this mounted to the bike. Got our axle sleeve all bearinged up. Now I just need to figure out a way to hold it to the bike. I need to build a bracket that solves a few problems. The shaft is going to be under high stress from the belt tension and pedaling forces. So it needs to be able to support the end of the drive shaft to prevent it from bending. Second, it needs to be adjustable for different length belts or for future pulley changes. It will also help with belt tensioning. And third, it must keep the shaft from moving forward and backwards. And of course, it can't damage the original condition of the bike, so welding is definitely out of the question. So in order to get started, I need to measure the relationship between this upper tube and this main post. And I'm going to do it with a level. This level has a top secret trick up its sleeve, and it has a built-in protractor inside. Now I can find the angle between these two tubes, flip it over, and it's a 71.7 degree angle. And that's exactly what I need to take it over to the water jet and get some parts cut. I'll leave a link in the description below where you guys can find it. So here's our rough bracket shapes that the water jet cut out for us. We're gonna have to trim them down to make them look good. But we also need to find a way to have these brackets grip the tube. I have a couple ideas, and it's gonna require going to the milling machine. The bicycle frame is 1 inch round tubing, and I would like a nice good cope to grip around the tube. So I'm gonna use a 1 inch ball end mill to make that cope. So why is this extra material here? This is so that I can put it into the clamp of the vise and get the axes. I'm gonna mill a slot right there. And now I can put that parallel in the jaws, and it sets me up to run a nice straight cut. And then we will cut this off afterwards. I'm gonna set 2 up at once. To achieve a cope, I definitely could have used a 1 inch hole saw, but the ball end mill gives me a lot of control on the tolerances, which means I can have it a little bit smaller so that it really grips onto the tube. Trimming away that extra material only took a few seconds, but man, was it handy to have there for the first initial setup. The bracket also interferes with the brake cable, so I had to make sure to make a slot for that. The bracket has a lot of sharp edges and some mill finish that I like to remove and blend in. So I'm using a ceramic deburring machine, and tumbling them for about a half an hour gives me the results I'm looking for. Boy, that looks pretty pro. Now that is just plain cool. In order to clamp it to the frame, I needed to tap some holes. This is going to hold everything securely. So check out the mount. Super strong. Got the angles correct. Clears the brake cables. But now I need to build a link to tie the tube to the mount using this slot right here. That way we can adjust the pulley tension when we go to install the belt. So let's go build the link. Even though this is a little tiny block and looks like a really simple component, it's actually really important. This is what centers the shaft over the lower pedal pulley, front to back and side to side. I'm welding it to the aluminum shaft to make sure it doesn't go anywhere. I've also installed a spare bearing to keep the tube from deforming when I weld it. It will be replaced later. So we got everything mounted up front. Now we need to focus on the back. And in Ernest's photograph, he has a bracket that goes from here down to the center of the wheel. And let's recreate that exact same thing because we know it works. The challenge with this support is trying to make it look like an original Schwinn part. I'm using 1/2 solid aluminum round and just bending it in a tight form around the wheel, something that looks good. The rear wheel axle is a great place to bolt on this bracket. It's really going to help keep the wiggle out of the propeller when it's spinning. Few good aluminum welds to hold everything secure. I definitely feel confident in having the support back here. Let's do a test with the drive shaft and the pulleys. Thrust washers on. Okay, let's put the belt on. Look at that, that is so cool. You have a shaft coming out the back. You have drive. So the funnest part about this whole build is building the propeller. When I look at Ernest's propeller, I actually have no idea how heavy it is. And it's really hard to tell what material did he end up using. Is it steel, aluminum, plastic? I have no idea. Or what pitch angle did he find worked the best? Ernest's propeller is definitely not flat, or I mean constant pitch. On a constant pitch prop, the blade angle is the same the entire length, which would be really easy to make. But it sacrifices efficiency. Ernest's propeller is twisted, or the technical term is variable pitch. This is going to be much harder to duplicate. A variable pitch propeller is going to maximize the efficiency of the power source. A good way to think about it is that a propeller is a big air scoop. And this air scoop puts torque on the shaft. The closer to the pivot, the more torque you have, meaning you can push more air. Closer to the tip, air has the most leverage, meaning it should push less air. So to maximize the prop performance, we need to push more air near the pivot and less air near the tip. So let's try to recreate Ernest's variable pitch propeller, and we're going to start on the water jet. Taking a look at Ernest's propeller again, it looks like he used layers of sheet metal, but that's probably due to prototyping increasing the propeller size. To keep the weight down, I'm going to use this 16 gauge aluminum, which I think is going to work great. I'm also going to try to match the profile and the size of the original as closely as possible. All I can do here is estimate. If I get it wrong, we can try again. That's
comfortable, stylish, and 100% waterproof.
Shoes.
So here's the part that just came off the water jet, and this is going to make up one side of the propeller. Now this is the closest I can come up with as far as looking at the photograph and copying the design. I can tell Ernest mounted the propeller to the shaft that's probably about 8 to 10 inches, and this is going to stick out flat. Now the hard part is, how do we curl this big, huge, flat blade in some sort of spiral shape? In order to create the spiral, we're going to have to come up with some compound bends, and they're going to have to be bent along this grid line. It is going to be really challenging to do, and then not only to do it once, but we got to do it twice. But I have one trick up my sleeve. This is the beast that's going to help us out. This can roll steel 48 inches wide and up to 3/16 of an inch thick. This is not going to be a problem for this thin aluminum. I'm using this tool because it can roll cones. And how it does that is it tilts this back roller so that it's tight on one end and loose on the other. And this is going to give us that gradual bend that we need. This would be really hard to do with a press brake, but I'm going to use it like a press brake. So I'm going to try to do this with both of them together. So because this is corner is the tightest bend. It's gonna go up tight where these two rollers are the closest. And then down here, I want the bend to be really gradual, and that's gonna be the loose end. Start somewhere there. All I'm gonna do is raise the roller up by hand. If I tried to use the power feed that this roller is capable of, it would wreck this propeller blade in 1 second. So I have to make sure to do it by hand and go nice and slow. Also, the ends of the propeller blades need to remain flat, so I can't roll the whole propeller blade through the roller. Take a look at that. Problem number 1 solved, got blades. Problem number 2, how do we attach it to the bicycle? I want the propeller blades to cross the center line of the shaft. So I'm going to build an attachment hub that gives me that opportunity. So we need to create a slot and some way to pinch down onto the blades. This hub design is going to allow me to engineer new blades if I need to and just quickly replace them. The hub is going to be experiencing a lot of torque, so I'm building out of some 1.5 inch solid aluminum. I also want this hub to fit really tight on the shaft. That way this is going to reduce the vibration.